Hello and welcome to my channel. In this video we are going to solve a question from circle theorems. Now this question has two sub-questions. So let us start with the first question now. The points A, B, C, D and E lie on a circle. FG is a tangent to the circle at point C. Angle BAD is equal to 110 degrees. Angle ADB is equal to 20 degrees. And angle BEC is equal to 45 degrees. So the first sub question is find angle BCD. That is, here we need to find out this angle, that is angle BCD, and give a geometrical reason for your answer. So here we have been given 5 points A, B, C, D, E on the circumference of the circle, and FG is acting as a tangent to the circle touching at point C. Now here some angles have been given to us. In the first sub question, we are supposed to find out this angle, that is angle BCD. So to find out this angle, we have to use a circle theorem, which is cyclic quadrilateral theorem. It states that the opposite angles of a cyclic quadrilateral add up to 180 degrees. Now here we can see that a circle is being drawn and a quadrilateral is drawn inside it in such a way that all the vertices of the quadrilateral touches the circle. Now when all the vertices of a quadrilateral touch a circle, we call it as a cyclic quadrilateral. Now here ABCD becomes a cyclic quadrilateral because all the vertices of this quadrilateral are touching the circle. Now according to the statement of this theorem, the opposite angles of cyclic quadrilateral will add up to 180 degrees. Now here we can see that angle A is opposite to angle C. So according to the theorem, angle A plus angle C should be equal to 180 degrees. Similarly, angle B is opposite to angle D. So angle B added with angle D should give us 180 degrees. So let us see how we can use this theorem to solve the question above. So here we can see that ABCD is a cyclic quadrilateral because all the vertices of this quadrilateral are touching the circle. And in this cyclic quadrilateral, angle A is opposite to angle C. So they will both add up together to give us 180 degrees. That is by using cyclic quadrilateral theorem. So here we have written angle A plus angle C is equal to 180 degrees. So since we have to find out angle C, let us take angle A on the other side of equal to sign. So we get angle C is equal to 180 minus angle A. Angle A value is given to us, that is 110. So 180 minus 110 gives us the value of angle C, or the value of angle BCD as 70 degrees. So here we have written angle BCD is equal to 70 degrees because ABCD is a cyclic quadrilateral and hence the opposite angles add up to 180 degrees. Now the second sub question is find angle DBC. So here we have referred the figure for easy reference. So here we need to find out this angle, that is angle DBC. So for this we have to make use of another circle theorem, which is angles in the same segment. It states that angles in the same segment are equal. Now here we have drawn a circle and we have marked 2 points on it, that is point A and B. Now these 2 points divide the entire circle into 2 segments. One is the smaller segment called as the minor segment, and this is the larger segment which is called as a major segment. Now according to the statement, the angles made in the same segment are equal. So let us consider these 2 points and start drawing some angles in the major segment. So let us consider this is one of the angles made by these 2 points in the major segment. And using the same 2 points, we are going to make 2 more angles in the major segment. This way. Now if we say that the angle made by these 2 points A and B at this point is going to be 30 degrees in the major segment, then the angle made by these 2 points at this point and this point is also going to be 30 degrees because these 2 angles are made by the same 2 points in the major segment. So angles in the same segment are equal. So let us see how we can use this theorem to solve the example above. So let us consider the 2 points B and C over here. Now these 2 points divide the entire circle into 2 segments. One is the small segment called as the minor segment and the other is the larger segment, which is the major segment. So we can see that these 2 points make an angle at point E, that is this way, and the same 2 points make an angle at point D this way. And since the angle E and angle D is made by the same 2 points in the major segment, the value of angle D is also going to be equal to 45 degrees. That is by angles in the same segment theorem. And the value of angle C we had already got in the previous part of this question as 70 degrees. We have marked it over here. But in this question we are supposed to find out angle DBC. So for that, let us consider the triangle DBC. So consider the triangle BCD, and using the angle sum property of the triangles, we have written angle B plus angle C plus angle D is equal to 180 degrees. Now since we need to find out angle B, we are going to take angle C and angle D on the other side of equal to sign. This gives us angle B is equal to 180 degrees minus angle C and minus angle D. Now we have the values of angle C and angle D with us. So 180 minus angle C is 70 degrees minus angle D is 45 degrees. So 180 minus 70 gives us 110, and 110 minus 45 gives us 65 degrees. So this is the value of angle DBC. Find angle DCG. So here we have to find out the angle DCG, that is this angle. And to find out this angle, we have to make use of another circle theorem, which is alternate segment theorem. It states that the angle that lies between a tangent and the chord is equal to the angle made by the same chord in the alternate segment. Now here we have drawn a circle and we have drawn a tangent AB touching the circle at point B. Now we have drawn a chord BC from the same point B in such a way that the chord divides the entire circle into 2 segments. One is the small segment called the minor segment, and this is the larger segment called as a major segment. Now we have marked a point D in the major segment. Now let us say that this chord BC makes an angle at point D in the major segment this way. Now let us consider that the angle between the chord and the tangent is going to be 45 degrees, for example. And this angle is made by the chord with the tangent in the minor segment. So according to the theorem, the same chord is going to make the same angle in the major segment. Now since the angle at point D is made by the same chord but in the major segment, this angle is also going to be 45 degrees. So this is the alternate segment theorem. So let us see how we can use this theorem to solve the example above. Now here, since we are supposed to find out this angle DCG, let us consider the tangent FG and the chord CD. Now here we can see that the chord CD has divided the entire circle into 2 segments. One is the smaller segment called as a minor segment, and the other one is the major segment. Now we can also see that the chord has made an angle in the minor segment, that is angle DCG, and the same chord makes an angle at point B in the major segment this way. And we had got the value of angle DBC in the previous part of the question as 65 degrees. So by using the alternate segment theorem, we can say that the value of angle DCG is also going to be 65 degrees. So this is going to be our answer. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.